Okay, well, I am, there we go. 1 second. Okay, so what we're going to be doing tonight is we're going to be trying to, I have worked on this a little bit off stream, an OpenGL engine for OpenGL, specifically for the Raspberry Pi 2, sorry, Raspberry Pi 5. And if we go VNC, we go to Pi 10 here, and then if we go here, open up a terminal. You can see that I have a spinning, rotating, I have a rotating cube with a shader, with a GLSL shader, and one of the what you call it, vertices is turning. So if you go here and you go to here, you can see that this program is fairly simple. Basically what I have is I have a cube vertice array of floats. So we have 8 vertices because it's a cube. Yo, that's the reason I'm doing OpenGL is because I don't know, I want to learn it more. And yes, I could do Vulkan for the Pi, but that's a stretch goal here. I don't know. I've just been I've been doing some OpenGL stuff on the Pi before, and I just want to learn it some more. And I know it's old, but old's good, right? And it is somewhat, transferable, but Anyway, so I have an array of 8 vertices, and then I have cube indices. And what the indices is basically, this is telling the program how to draw the triangles for the cube, saying which indices to go where. So I hop from indice 0 to indice 3 to indice 2, and then 0 to 1. So that's just basically telling you how to wind the cube. Really just gotta shout. Yeah, get dressed. Be decent here. Anyway, so yeah, the cube indices are for how to wind the cube. And then this is the prototypes for mostly for shaders and the OpenGL callbacks. Read file, it reads in the shader file, load the shader. Basically it loads the shader, and then it compiles the shader and then create shaders. You have to create a handle, vertex shader and fragment shader, to create the handles from the shader files, and you have to attach and link the program. That's the whole thing. OpenGL is kind of a nightmare. OpenGL 2 especially is a nightmare. And then cleanup just deletes the shader program, the buffers, and stuff like that. And then the display callback, you set your depth buffer bit and color buffer bit, and that's to set depth depth, because say I draw, okay, let me show you. Let's say that you're drawing this, and you draw the front face first, and then you draw the back face. But if you don't have depth on, because you drew the back face last, it's going to be in front. So you have to have the depth bit on depth buffer so that it knows to not draw the back in front. Load identity, so make sure you're in the matrix mode. Load identity. Make sure remember for OpenGL you want to translate to where you want to draw this stuff. So you're going to translate -3 into the z-axis, and then you're going to rotate. And the rotate angle is going to be constantly changing. In the idle function, don't try not to do your logic in the display function. Try to do your display stuff in the display function, and then your logic in the idle function. That's just kind of how it works. Then before you draw, make sure you use your shader program that you've compiled which we have, enable client state vertex array, so we're going to be doing the vertex array mode. And I want to bind the cube VBO, vertex buffer object, as an array buffer, okay? And then I want the pointer to offset into memory this time, okay? We're gonna offset into memory, because we're not gonna do CPU side, and the offset is 0. And then we're going to bind the index buffer object as an element array buffer, and then we're gonna have 36 elements, you know, 0, an offset of 0 into the GPU memory, and then we're going to unload each array after we draw. Now, remember, basically what I could do also is I could do GL quads if I really wanted to. I could draw the cube as quads. It would be smaller. Would it be faster? I'm not really sure. It's just common to older stuff, and then you unload the shader and all that stuff, and you swap buffers to draw. Reshape happens every time you resize the window, but it also happens once when you open up the window. So this is what you set the perspective. You want to set perspective mode, not orthogonal mode, because orthogonal mode will be 2D, but you can still do 3D stuff. It won't look right, but maybe depending on what you need, it will be correct. Idle, this is where you're going to do like the logic for, okay, we rotate the cube here, rotate angle, and then a vertex animation phase. This is where we want the circle, because one of the vertices is going to be on a circle track. And basically what you do is you create, I could probably do this a little more streamlined, but you create like sort of like a sinusoidal wave. I want to move up and down. And you create new coordinates for that vertex, and then you do buffer subdata because I want to insert that at location 0, because this is index 0. This is the first vertex that you draw, and then you bind buffer to it. You edit the buffer, and then yeah. So I could literally just do new y and, a pointer to new y. I wonder if I can do that actually. Here, let me try that. Because I think that's kind of stupid that I have to like update everything, Let's try that. GL buffer sub data. GL array buffer. We'll do 1 because it's going to be the second index. Size of GL float. And address of new y. Cool, let's try that. Oh, right. Let's get rid of all warnings. Well, it doesn't seem to work. Why does it not seem to work? Why is it not working? Buffer, size of float. Maybe? No. Well, needs to be a void pointer. There's no way that does anything. I don't know. I couldn't tell you why that doesn't work. Well, it don't work. Okay, well, there we go. It works. Let me continue on. So anyway, right, you do post redisplay. You do redisplay in the idle because that will tell OpenGL to run display again. For some reason, it doesn't run display every time it loops. Don't ask me why. 1 second, let me get some ramen here. Okay, now let's carry on. So, we're in the main, glue in it, initialize glue. Display mode, make sure you use the depth, double buffering, RGBA for color. Okay, make sure the window is 500 by 500, open it up at 100, 100, and just call it square. And then glue in it is specifically for shading, because I want to use the shader 1.20. Create shader, that's one of the functions I have. Clear color, just clear the screen. Enable depth testing. GL depth test. Now this, it works on the Pi, I think, kind of, but do be aware this won't work on every piece of hardware. I literally had NVIDIA GPUs and AMD GPUs behave completely differently. Basically, what would happen was I would have a stack of shapes on the z-axis, and AMD behaved correctly. Like it would draw like the first one in front and the back ones behind, but NVIDIA would have them all visible all at once. So sometimes you might have to you might have to like do your own depth testing of determining which one's farthest away from the camera and draw that one first. Clockwise, the counterclockwise for winding. Apparently, that is normal. You do counterclockwise for winding. That's how you draw. That's how you draw stuff in OpenGL. And I did face culling with backface culling specifically for optimization. Again, buffers when I create the cube buffer, bind it, the index buffer for the cube, and all that sort of good stuff. Then have the callbacks for the display, reshape, and idle. And when you close, run the cleanup function. Now the problem here is, how do you take this and turn it into an actual engine? Basically, okay, that's what's up. I just did a full breakdown of the of the working OpenGL of this. Yeah, I'm sorry. I went over exactly how this worked. Basically, I have a vertex buffer object and an index buffer object. I have a vertex buffer object to hold the number of vertices for this. Oh, no, I didn't make it through any breakthroughs at all. I just explained how this worked. So basically there's 8 vertices, and then I have 36 indices in the index buffer array to tell the OpenGL how to wind the outside to draw it. And then I add a shader, which basically calculates normals on the fly and shades depending on the angle of that normal. That's like the easiest way to do it without lighting. So yeah. Now, I have to figure out how to turn this into an engine. Did you start making this because of my game engine limo? No, but it certainly inspired me a bit. This is something a little more like there's more to it, but yeah. Let me get some more ramen because oh my god, I'm starving. Man, ramen's so good. Anyway, so I want to make this thing in C. My god. Dying. Is that you haven't? No. I haven't implemented the actual engine. So the thing is, you can draw in OpenGL just fine, and I can draw in OpenGL just fine. But I want the programmer to not have to touch OpenGL. And I know there's Euro 3D. Actually, Euro 3D is a fantastic game engine. In fact, like, what? What? I don't know. Basically, like, you can create, Euro 3D, sorry, I've used it before, even on the Pi 2, it's fantastic. It is fantastic. Back in the day, I mean, there was like a couple problems, but, like, for, like, very complicated stuff, but no, this is fine. Euro 3D even does, like, bones and stuff. What is ECS? Entity software architectural pattern mostly used in physical games. Yeah, compose data with assistant. Yes, actually I am. I am using essentially ECS actually, and I'll show you. So this is kind of the map I've sort of sorted out. So basically, I'm gonna have an Euler angle struct. I'm not gonna use Euler angles. I'm gonna try to use quaternions because Eulers kind of suck. They're fantastic, but like you get gimbal lock and stuff. And you're gonna have a transform. You're gonna have your position, your rotation, scale, world matrix, and all that stuff. You might see Versor. Versor is just a type name for a quaternion for the GLM library. CGLM library. You want me to look up what? Flex. Fast entity component system. Lightweight entity component system lets you build games and simulations with millions of entities. Join the Discord. Here are some of the fragments. Vast and portable and data dependency. What? 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 Hang on, what? What is this? Oh. Oh. So, okay. This is, okay, so this is cool, but it's probably not quite what I want. Yeah, yes. Yes, that does look, it looks pretty. look, the loads look pretty sick though. Scroll down, more on the readme lol. Well, let me find out. Let's see here. I'm gonna put a registration. I want to get coding in this. I don't want to just sit and read all day. Lol. No, no shade, no shade. What? I like how it's insert an entity, but you don't even know what the entity is. But that's crazy. That's really cool. Huh. Um. Right, entities hold data, but like, how do you systems edit data based on the components of the entities? This looks really cool. I have to give it a shot. Oh, I see. It uses CGLM, lol. That's very intriguing. That's very intriguing. Huh. I'm sorry, guys. I'm just fucking starving. Okay, one last thing to look up before I just go to code. Huh. Okay. I might be a little sold here. But I gotta get coding here. Basically, back to what code is here. With transform, you have a mesh struct which has the vertex buffer object and index buffer object, as well as your draw mode. Vertex count, index count, all those good things. You got your texture, which is your texture ID, which you have compiled, and your texture size and coordinates. You have your shader, which uses a texture, I think. No, which can use a texture, yeah. And then you have a material which uses the shader and all that stuff. And then you have your game object, and your game object is specifically supposed to be for, it's supposed to be for, like, drawing a cube or drawing a square or a triangle or something. And then you have a camera, that's just your view. And then your scene is going to be, so you can have multiple scenes in this engine. Basically, I want to have like a 2D scene and then a 3D scene, and you'd be able to rapidly switch between them. And as you can see, they have function pointers which you will assign to things like your OpenGL callback functions, right? And then the engine. I don't care about shaders and texture managers right yet. I just want to get a square being drawn, but I'm kind of far away from that right now. Then, here, ELAB engine. This is the forward-facing. This is the forward-facing include. This is the one that will be seen by the programmer, and this is what you will include in your program. Basically, I have to figure out how to make this. I have my definitions, now I gotta actually fill them out. So the thing here is engine ng. Where are you seeing that? I don't doubt that I totally mixed that up. Okay, this is actually probably, ow, damn. That's probably not what I want. This is probably what I want to do. This is this. I'm going to go here, delete. New file, engine.c. Cool. Because then what I'm going to do is include ELAB engine h in the initialized graphics, huh? You got a good eye, Des. You got a great eye. And then engine and scene. So I'll do engine scene dot. Oh shit! Sorry. I will do scene.h eventually, but I'll have it all in one thing right now. And then camera.c. Cool. Actually, dyslexic? Nice. Well, there you go. Even you can read my crappy code. Chicken ramen's pretty goated. Should I put an egg in it or something? Excuse me for my disgusting sounds. Okay. Basically, this is what I gotta do. I gotta do these functions. Okay. Engine life. Okay. So let us create an engine. Yeah, I know it's not nice, man. So let's do this. Engine equals malloc calc let's go to globals and do and error code. Okay, function code return. Cool. Basically what I want to do malloc size of engine. I think that works if let me look up really quick. Yo, Nico, what's up? Sorry, I'm looking here and my Discord, my OBS is on the side. I want to make this engine robust. Okay, let's see. Malloc. Realloc, return value. Malloc, calloc, realloc, and realloc array return a pointer to the allocated memory. Attempting to allocate more than is considered error. These functions return null and set error null. Yeah, but what is error null set to? That's my question. Attempting to allocate more is considered an error. What does error null get set to? Because like if I have error.h included, I can figure this out. Error null.h. Okay, we'll just see if it's null. Okay, we'll just see if it's null. If not. Okay. There we go. If not, engine equals malloc size of engine, then printf error how do I super space? I'm hitting the if statements with your brackets. You don't like the you don't like this? Yeah. For me, it's just easier to read. Oh, you have a create. Well, you know what? Screw your code style. Basically, okay, cd. Everyone's doing code styles. Yeah, we all do. Returning int from function. Maybe I should just do null, right? Yeah. Okay, let's try this. Right. I knew that. Null is undeclared. I am sorry. Is stdlib not included? What? Globals. CGLM, no such file or directory. Okay. This is going to be the problem. How to install CGLM. How do I install CGLM? How to install CGLM? libcglm dev. Okay. Let's try that. Sudo apt install libcglm dev. Cool. Cool. Okay, let's try this again. From elab engine into here. What? What? Why is... Oh. Why is this not working, folks? I'm so sorry. I'm sorry you're watching a boring stream. elab and structs '67. It includes globals. I guess I'll do that. Oh, wait, what am I doing? Wait, what am I doing? GL. OpenGL type. So we have, here we go. Format size. Okay, so this will be GL size. There. Okay, that's what was going on. Okay. You triple tasking? Yeah, I understand, man. What's up? What you doing? This scene. Wow, I can't believe I am this bad. Yeah, let's try this again. Okay, let's look. Let's look. Bool elab engine H. Why do I have to include std bool? What's going on? Warning, type defaults to int and type name. 24. Why? Why does that default to int? Actually, what am I doing here? There. That's better. elab engine.h. 29. It's because of this. Yeah. Undefined reference to main. Basically, that's just saying because I'm making a library, I have no main. And then I that'll be a CMake thing. That's gonna be a CMake thing. So we're good there. Whew. Okay. Let's get into this. So we're going to make an engine first. We want to create an engine. And it'll take nothing. So I think if you look at an engine, I'll do colic. There. Cool. Okay, so I do colic to set everything to 0. So that way, these numbers will always set to 0. Now, okay, 0 in a double and 0 in float is not actually 0 hex, but whatever, right? Okay. That looks good. And then destroy. Free engine. I think that should be self-explanatory. Freeze allocated engine space. Creates engine. Now, I think I would want to do this too. I want to do free engine scenes. I want to do that because then I don't like have a floating pointer. And I think scene I'm going to free the game object, free engine scenes game objects. I need to free that linked list too. And these are just function pointers. These aren't malloc, so that's fine. I don't need to free these. Let me look at game object and see if anything is there. I gotta free a mesh and material. If you want your stuff robust, you gotta do this. And transform pointer to the main shader texture program. Good God. Oh my God. The things I do for robustness. Mesh should have no other pointers. Nope. There should have no pointers. Okay, let me try compiling it. What? Oh, is that because this is the first point? This is a pointer. So seeing this as a pointer, but what you can't point to an you can't like offset the offset essentially. It would make no sense. So this actually would be a dot. Oh my God, I'm trying to switch between you know, Notepad++, and this. Let's try that. Request from member game objects in something not a structure or a union. I'm really confused because I guess I'll have to delete these for now. Who cares about memory leaks anyway? They just feed the engine only because everything under is no. You can't. You cannot do that. You cannot free a pointer and expect all the pointers that are in that structure to be freed. That's just not how it works. You have to free each individual one. That's why memory, like garbage collection, is just a fucking nightmare in C. In C sharp, C++, and C sharp, and all that, where like there's actually like data structures that handle all that stuff. Then that's fine. This is completely different. You can't do that. Well, your memory allocator isn't rated in C, so there's that. Okay. Elab pool. So let's see. Call us after geo windowing has been done. Glut SDL and THW. This is where glue should be initialized. Okay. So initialize graphics. You have alloc, free, realloc, and everything. Really? Wait, how does your stuff free memory? Because as far as I can tell, you have to free LIFO, last in first out. So you have to. So no matter what, you got to free stuff. Not even LIFO. It's just whatever you've mallocked. It's going to remain on the heap. How's it going to know it's being pointed to? Recursive because I know what was a pointer and what's just an int. My God. Okay. Well, I'll take your word for it. I'm not going to make my own memory allocator. So I'm not quite sure what this is supposed to hold, but nothing works without the schema. Okay. Oh, schemas. Okay. And what I have is just Boolean if it's just a pointer. Not. I gotcha. Okay, so then basically we're going to do this. Scene management. So we're going to do pretty much the same thing we've done here. Which is why I can recurse from just a single if check. I gotcha. Okay, so basically we're going to replace everything here with scene. Then what we're going to do is we're going to do scene so we're going to do I should probably know this stuff by heart. Codegen 2, Codegen schema, that's pretty dope. Destination source. Cool. Okay. And then destroy. So a scene is not the engine, remember? An engine has scenes, but you can destroy scenes on their own. Let's try this. Really? Well, I guess I just can't have things offset. Oh well. Then I'm going to add a scene. Okay. Dynamic list of scenes, possibly changed to a C vector. Yeah, how do I do vectors in C? Like, so vector itself is actually really just malloc. What vector does, no cap, on God, for real, is it takes your initialized size and mallocs it. And every time you realloc something larger, like you add something to it that would go off the end, it'll just realloc something even bigger, and then have that in the type for max size, internally hidden away from you. So you have no idea, but it's using malloc and realloc and stuff and free like constantly. It's just completely abstracted away from you. So this right here is it's what vector is. So it's totally fine. I'm sure someone has a vector image somewhere. What are you doing? What is this? Complete BS. That's so stupid. Anyway, basically, you have a double pointer, and I want to stick this pointer onto the stack. Let's have max 01. Yeah, it is 01. Interesting. You should just throw a TLSF allocator into it. Well, look, this is for functionality first and then optimization later. We're not gonna get caught up in this bullshit. I totally understand where you're coming from. Oh, so when I break it down, it's fairly easy to do. Like, do this function, do the next function. Basically, what do I want to do? I want to do like max buffer max buffer size. Let's just say 64. Okay, we're gonna say 65. Then, basically, what I want to do is I want to do malloc engine scenes equals times size of scene, a scene pointer, right? Okay, so basically we're gonna malloc max, but I'm just going. It's not even going to be dynamic at this point. It's just going to be static. I'm going to make it 64. Later on, I will have a dynamic pointer, and it'll be a vector. We'll have that, right? Okay, if it can't malloc it, sorry, folks. No, for scene array space looks about right. What is this? Control reaches end of non-void function. Cool. Okay. So basically, now I have to add it on. Which means I need a counter. I hate this. I hate this. I hate this. This is why classes are fantastic, folks. People. Oh my god. Don't want to see my crutch. There. Oh my god. My god, this is a nightmare. Hang on. We're good? We're good. Sorry about that. My special boy. Basically, I need a bunch of hidden variables. I need a bunch of hidden variables for y'all. So, int elab scene count cool. If it's greater than okay. Printf std error max number of scenes for this engine reached. Okay. Boom. Cool. Okay. And if not, then we have to add the scene to the engine. Engine how do I do this? Plus elab scene count. Let's try this. Okay, so we're doing an offset, hopefully cast to that scene's size equals scene. I've literally no clue if this is going to do anything. Okay. Cool. There we go. That worked. I don't know why that was so hard for me. Okay. So we have add scene, create. We have create. We need engine, scene, camera. We need game object. Okay, we're not gonna like finish this, and I might restructure this off camera, but yeah. So then we're gonna set current scene by name, but I think if we look at engine, current scene index. Oh, size, state, capacity, scenes. I have this number already here. What am I doing? I'm making things harder. If I just look at what I programmed before, folks, do not overcomplicate things. Just don't overcomplicate things. It's not necessary. Look at this. Look at this. Look at this. Watch. So if we go to here, okay, and we go to, oh, I have to do all this fucking logic to add scenes. No, that's totally fine. So basically what you gotta do is this. If engine num scenes is greater than engine capacity scenes. Cool. Right? And then so then basically, folks, what I'm doing is I'm going to take, I'm basically just using the internal variables to take care of my stuff instead of relying on, external variables that just aren't really needed. Cool. Look at that. Look at that. What's going on? Where is this? Engine. Cool. Hang on, what? Okay, this is actually an interesting thing. So basically, I need to figure out how many scenes you can have. So scene create, scene destroy, scene add scene. Let's just say we're getting 64, okay? Refigure out scene pointer allocation. Yeah, because we have a magic number 64 here. That does not need to be magic number. Okay. Basically, what does calloc do? Does calloc set to 0? Calloc shall allocate all bits to 0. Okay. What is a size T? What is a size T data type? I literally don't care. What is the actual size T data type? Any new progress? I'm making slow progress. I am making progress. We're filling in the functions one at a time. Size T is an unsigned integer type of at least 16 bits. Size T is an unsigned data type. So size T is essentially a type def. It's not like a this is a struct and this is okay. Probably could have figured it out on my own. No worries. That's in. Right, so what I'm going to do now is I'm going to. This is the fun one. So yeah, basically what I'm doing, and to anyone who's listening, is I'm just running through the list that my public facing include will have. And I'm just filling in the seed files. I'm just filling them out. And hopefully they're going to work seamlessly together. This kind of wants you to set up OpenGL on your own. But see, the thing is that OpenGL is a state machine. So if I do initialize graphics, I could probably just put OpenGL's initialization here. Because a state machine is a state machine is a state machine. It doesn't matter. Which also is really nice because if you wanted to do more intrinsic atomic stuff in your game, you can just use the OpenGL function and it'll just be there. In fact, you can include any other OpenGL library you want and it'll affect it still. That's a feature, not a bug. So basically what I have to do is I have to search. So for size T, I equals 0, I less than engine, num scenes, and then num scenes will be set up in engine. margin num scenes equals 64. Cool. What about the other stuff that does the actual rendering? We haven't gotten there yet, bro. We have to. Wait, we have to get there. We gotta get there. So basically, we gotta get there. You know what? Next stream, actually, I think I'll jump to that. I'll look at what I can do, because like I don't need the camera stuff. I don't need any of the other stuff. I just need. Let me finish my train of thought here, and then next stream we'll get to the actual drawing, and that will be where we're actually like, okay, we're gonna be stress testing this. We're gonna see, can this actually work? And ideally, I want to make this with minimal AI help. Minimal. So this, by the way, also, if you don't know, this is being rendered on that Pi over there that has the lights blinking. That's a PDP-10 emulator. I'm doing this as a wireless and headless Pi that's being rendered over, VNC. So I think that's pretty cool. Okay. Imagine I'm testing the Chromebook. What you're doing WebGL stuff, right? Not WebGL, WebGPU. Right. I'm sorry. Always on the same hardware. WebGL sucks. Yeah, it's Vulkan and whatnot. Yeah. Cool. I think that will work just fine. Isn't yes. There we go. Do I have to do a pointer? Maybe it is a string. Cool. Yeah, things we learn. It's actually really insane what you can do with, like... Seriously, again, look at these functions. They're very small. Engines are easy. I just have to not be stupid and just think on how they actually work. I want to do, like, actual videos, VODs of, like, Raspberry Pi OpenGL, because I actually have a great progression of, okay, you're drawing squares using the GL draw, but then if you don't want to do that because that's slow, then how do you do draw arrays, you do draw elements, you do draw subarrays, so like, and each one is better and better, and then you do a draw list where you compile an OpenGL program kind of on the fly and just rerun it every time until finally you hit vertex buffer objects, and that's what you really want. You really want a vertex buffer object, because vertex buffer objects run almost completely on the GPU. The only CPU calls is just to change and update the vertex buffer object data, which you can do not on a compiled GPU OpenGL program, which is what the display list is. It's like you can't change anything. Like cogen and 50 different build steps, right? Yeah, if you just break it down, it's easy. Nothing I'm doing here is revolutionary. In fact, this whole engine is revolutionary. Tomorrow, we're going to do a stream tomorrow, and it won't be on this. I'm sorry. It won't be on this. But tomorrow, stay tuned, because I will be building an infrared camera on stream. On stream, I'll be building an infrared camera. 8 by 8 pixel infrared camera. Using a Pi? Using a Pi Zero? Something? Yeah. The engine is already done. It's just everything else. Exactly, man. Exactly. It's all there. You just gotta pull it out of your ass. Okay. Let's continue on. Set by current, scene by current index. Well, this is easy. So if scene index is greater than engine so I should also put a count on this, which is, let's see, engine number of scenes, your capacity of scenes, your number of scenes you have. Right. Okay, I got you. Okay, I got you. Your number of scenes. If it is greater than your number of scenes, then you're off the edge. Or scene index less than 0. Okay, obvious. Turn false. fprintf std error. Invalid scene index chosen. Okay. If not, then engine scene current scene index cool. Okay. I wish I had everything linked up. In fact, this isn't the final build. What you call it? Structure. Everything in the same folder. I gotta break it apart into actual files and folders and shit. And then obviously I'm gonna make a CMake file, so it will actually build each individual file in the folder. And I basically have a big CMake. They go the smaller CMakes, and so each folder will have its own. So like scene folder will have a CMake file. Camera will have a CMake folder. Game object will have a CMake folder file, and then you have the master CMake file on the outside. You run that, and it just does everything. And I've done it before. It's simple. I just gotta remember how to do it. I'm having a great time. I hope you're having a great time. I know there's not very many of you, and you. Please, I appreciate each and every one of you guys coming to stop by. Okay, current scene. So I need to return a scene. Okay. So basically what I need to do, return engine scenes engine current scene index. Cool. Isn't it that easy? It's that easy, folks. It's almost like I've been doing this shit for like 9 years, 10 years. More, technically, but I only seriously about 8 years. Game object management within a scene. So let's go here. Are you having a good time? I hope you're having a good time. I'm having a great time, actually. This is really fun. I really need to do this more often because, like, streaming holds me accountable for my project. Because if I'm not streaming, I could be playing Doom: The Dark Ages, which by the way, Doom: The Dark Ages kind of fucking sucks compared to the other Doom games. It's a real shame that Mick Gordon had to leave. I mean, he kind of had to, but you know, Bethesda shafted him for the game music, so he didn't return for the Dark Ages for the music, and it shows so much. Now, I wish I could tell you that the new guy did the composing for this game, like followed in his footsteps. I can't even in good conscience say that he did. It's really not memorable, and because the music kind of sucks so much because Mick Gordon's way up here and the current guy's way down here, it really brings down the gameplay, and the gameplay is already slower. It's not slower. It's wildly different to the effect that people have considered it the worst Doom entry in the latest series. I'll finish the game. It's just friends of mine who are extremely passionate about Doom stopped after a couple chapters. So, yeah. Anyway, back to code. Mesh ID, I do the property. Yeah, okay. Don't worry about that crap. I know. I gotta fill all that fucking garbage. Yeah, sorry. I was just like, pointer, what? I can't believe it took me so long. And then the thing is, GameObject has quite a bit of stuff, if I remember. Basically, I need to like set this all up. So basically, when you make a game object, you want to include the transform, you want to include the mesh pointer, you want to include the material pointer, you want to include all these garbage fucking pointers. Yeah. The thing is, you have to create the game object with a scene pointer, which I don't know how that would work. I don't know why I wrote that down. Whatever. I created a pointer. We'll fill it out later, right? Cool. And then add game object. Oh, shit. Okay, let's try this out. So basically, if you're looking here, remember, folks, this is scene being passed in, not engine. Dude, like every single freaking. I have to do a good think about this, which I will. If we go to scenes, we go to scene, go to engine. We go to scene, number of game objects, capacity game objects. The scene and the engine is essentially the same thing. Cool. I could finish this and then head to bed because it is kind of late. I did start late. I'm really sorry about that. But tomorrow I'll start early. But tomorrow we're gonna be doing fun stuff. We're gonna be building. We're gonna be building a thermal camera. I can't wait. And what I really want to do is I really want to build a thermal camera with neon. Right? That's fun. We can do neon. We can do SIMD, single instruction multiple data, to make things go super fast. So please tune in tomorrow. Hopefully a little earlier, not 11 p.m. Eastern time. Cool. Hey, let's get this done. Dump game objects, capacity game objects. Cool. There we go. Double pointer. Yeah, that's right. That's right. Double pointer. Wait, what? Cool. That's built. Then, if I'm not right, so this I had to like add everything to. That's totally fine. So then, if I go to scene, why is void? Should get to a bool, my guy. We'll also need to do a remove object because sometimes you might want to remove an object, which means you have to pop it out and then push everything down. And I could do that with like pointers or pointers. Basically a linked list. So basically a linked list where I take the two elements on either side of the index that I want to take out and have them point to each other instead of through the middleman, and then free the middleman. I could do that. But that'd be me creating a vector. So basically, if the number of game objects, the increased number of game objects is greater than the capacity of game objects, then max number of but because I don't have that, that's totally fine. Cool. Cool. Okay. So then, scene, game, objects, scene, game objects. Let's go. What is this? Suggest parentheses around assignment that says truth value. What? What? Suggest parentheses around a sum used as truth value. Well, screw you. I'm not really sure what that means because it works. doing. There. Yeah. That's right. Okay, because if I did that, then other things would happen. Other things would happen. Cool. Well, see how I have add and then remove game object? The problem with remove game object is I will have to make things a vector or of some sort. So I think I'm going to head off to bed tonight. Not tomorrow, because tomorrow we're going to be doing the thermal camera. Please tune in for that if you want. If you want, please subscribe and tune in for that if you want to. If you want to do that. Watch me make a thermal camera live on camera. We're going to be using Adafruit parts, Pi Zero, and a little TFT display. And I'm going to try to set up a little like, solder station and camera so we can actually build it and then test it. Or use a teensy, you know. There's always that. Well, I'll head to bed. I'll think on this, and I think Friday or Saturday I will stream and read, not redo this, but like add on to this, make it more robust, and hopefully we'll be able to draw. We'll be able to draw something using this engine. Okay. Good night, guys. I will see you next time.